Welcome to the cooking channel and to right, mathematics. Okay, so let's do a bit of maths. Now what we're looking at today is tree diagrams can be useful. I mean, we've seen they were useful in trying to pick out probabilities. So our scenario here that I've constructed is I've got some fruits and vegetables here, and I want to see the probability of, I'm going to pick out something, I'm going to look what it is, going to put it back in, and then randomly going to pick something else and see what it is. And we can look at some probabilities, like what's the probability of picking out 2 apples. So what's the probability of picking out an apple, going, hey, that's an apple, cool, and then second time round picking out an apple, whether it's that same apple or a different apple. Or what's the probability of picking out the potato, putting it back in, and then picking out the potato again. Now we're going to pretend that I can't just feel what each fruit is, but fruits are more interesting than having colorful balls. Okay, so let's get into it, shall we? So that's why I'm talking about with replacement. In the next one, we'll talk about what happens when you pick out something, maybe you eat it, and then you pick out a second fruit or vegetable. So let's just start with some basic questions to get ourselves into it. How many different types of things are there here? Okay, I count 3 because I'm counting apples as one thing, onions as another thing, and potatoes as another thing. So I count 3 different things. How many, so in our tree diagram, because tree diagrams are useful, not the only way to show this, we're going to say, well, let's look at this and say we could have 3 different things going on. Okay, and we said those 3 different things are, what are the 3 different things that we could pick from? Well, we've got apples, we've got onions, and we've got potatoes. Well, 1 potato, but still. Those are 3 things we could pick out. What's the probability of picking out an apple? Well, I count that there are 1, 2, 3 apples. There's 6 things altogether. So therefore, the probability of picking out a juicy apple is 3 out of 6. You can simplify this to a half, but let's leave it as 3 over 6. What's the probability of picking out an onion? Well, again, same idea. 2 onions out of 6, so 2 out of 6. Okay, and the probability of picking out a potato is 1 out of 6. Cool, I think we're getting this. So 1 out of 6. So we got this. That's easy enough. Then the scenario says the same. So I picked out an apple. Second time round. What 3 different types of things could I pick from when I'm picking a second time? Well, the same 3 things, right? We could have apple, onion, potato. Apple, onion, potato. So I'm actually just going to say pause. Fill in the rest of the tree diagram and go for it. Complete the rest. We've got this. Fill in all the probabilities and fill in all the rest of the tree diagram. I'll be here waiting for you. I hope you're filling in the diagram. I assume it's going to take a bit of time, so I thought instead of putting the pause there, I'll put the pause in right about here. Okay, so we are back and we're filling in the rest of our diagram, and we're going 1, 2, 3, apple, onion, potato, and our other 3 things. Let's go in purple. 1, 2, 3, apple, onion, potato. What's the probability of picking on an apple? Well, the scenario looks the same. So it's still going to be 3 out of 6. Probability of picking on an onion, 2 onions, 6 things, so 2 out of 6. Probability of picking on a potato, well, 1 out of 6. And all of these branches are going to look the same. So let's go for it. 3 out of 6, 2 out of 6, 1 out of 6, and 3 out of 6, 2 out of 6, 1 out of 6. Notice that within any of these, 3 over 6 plus 2 over 6 plus 1 over 6, what does that give you? Yeah, it gives you 1, because one of these things must happen. Once we picked out an apple, we must pick something. So if we add all these probabilities up, we must get 1. If we add all of these probabilities up, we should get 1. And if we add all of these up. So we're in our tree diagram. That's the meat of... anyway. So that's the heart of what we're trying to do. Now let's look at 1 or 2 probabilities. What's the probability that I pick out... So what's the probability that I pick out an apple and I pick out an apple? Doesn't matter if it's the same one. What's the probability of picking out 2 apples? Okay, so to work this out, if you haven't got it there, is we must first pick out an apple and then we must pick out an apple again. So therefore an apple a day, no, that's something else. So the probability of picking out 2 apples is 3 over 6 times 3 over 6 gives you 9 out of 36, right? Which we cannot simplify. So 9 out of 36, that's our probability of picking out 2 apples. What's the probability? We're just going to do one more for now to say, what's the probability of picking out at least 1 onion? What's the probability of picking out at least 1 onion? That's a goodie, right? Are you busy working on it at the moment? No music, right? Did you hit pause or are you waiting for me to hit pause? What's the probability of picking out, I'm going to put it like this, at least 1 onion? Go for it. I'm just putting it in a different color so I can highlight it. Probability of picking out at least 1 onion. Okay, so you're busy working it out. Maybe I should have hit pause here. Okay, so we're back. That pause, yay, so you could join. How are we going to do this? Well, we need to get at least 1 onion. So if on our first pick, we pick up an apple, what do we definitely need to pick up on our second pick? We're going to have to pick up an onion. So in our tree diagram, what that means is if we picked an apple, any of these 3 apples, it means we went along this branch. That's what that represents, picking out an apple. Which means our second pick must be an onion, one of these 2 onions. So therefore, we must have picked out an onion. So our probability of 1 onion, let's move it up here. We must have picked an apple and then an onion. That's that probability. Or, so plus let's add some other options. Or we could have picked out an onion and then it doesn't matter what we do afterwards. So 2 out of 6. That we're going to pick out an onion in the first go. Note that you don't have to say 2 over 6 times 3 over 6 plus 2 over 6 times 2 over 6 plus 2 over 6 times 1 over 6. You don't have to do each of these loops because this all adds up to 1. So it's just 2 over 6. Okay. Last option. If we picked out that lonely potato in the middle and said, cool, we got a potato. What must we pick out in the second option? An onion. Yeah, so we picked out an onion. So we've got an onion. So we've got 2 so we've got 1 out of 6 and we must have picked out an onion over there. So we've got 1 over 6 times 2 over 6. Okay, so we work all that out either in your calculator or we can go for it and say, well, 3 over 6 times 2, I'm going to work out in the background, but use your calculator, go for it. 6 over 36 plus 2 over 6 plus, that's 2 over 6, 36, whoopsie. This 2 over 6, if we times it by 6, is 12 over 36. So over 36, 6 plus 12, 18, 20 over 36, which we can simplify divided by 2 is 10 over 18. Now 8, 4 goes into both of those. 4 goes in there, 5 over 9. If you did it on your calculator, got one hiding somewhere, then if you punched it all in, it will simplify it all for you. But you do need to give it in simplest form. Maybe express this as a percentage. Well, 5 divided by 9, S to D, if we want to 55% times 100, I guess we could do, is 55.55555%, so 56%, round off to the nearest percentage. So the probability of picking out at least one onion, randomly, we're saying, you know what, I'm going to pick out 2 things, and if I pick out an onion, I'm going to eat it. It's more than half a chance that you picked out an onion when you picked out 2. Okay, so that's that. Next one's going to be same idea, but without replacement. So we're going to pick out, and then leave it out, and then pick from what's left. Have fun.